Let's start. Let me briefly introduce myself. My name is Nikita. I am working in PixArt in generative tools and effects team. So we mainly work on image editing, quality fix tasks, and creative effects. Today, I would like to talk with you about AI platform, which we built in PixArt for like 10 years. And it started with small filters creation, content classification, and evolved in pretty large platform which serves about 700 million requests per month and handles pretty different tasks with large models. So talking about our infrastructure, it's about 900 GPUs. Half is used for the training and second half is used for the inferencing workloads. We are developing and supporting like more than 80 AI services for pretty different image editing tasks. And one of the key things for us is the latency. So most of our workloads I actually limit it with 5 or 10 seconds. Otherwise, users actually won't wait and leave the application. So what I wanted to talk today about 3 tracks related to the research, engineering, and infrastructure. They've been always behind the platform. And for research, everything started with classic computer vision. Approximately 15 years ago, I still remember how I was trying to optimize workloads for the CPUs to get faster processing. And that was pretty hard experience trying to utilize your desktop to get a new solution. So at the same time, people tried to use more data for the trainings, and deep learning appeared, generative models appeared, and right now we are training pretty large models on large amount of data. But behind the scenes, you need to put a lot of efforts on engineering, on infrastructure, because NVIDIA is delivering new GPUs every year with new capabilities, with larger amount of memory, with better floating point operations, and you need to utilize it properly. Otherwise, this is just a waste of money. So I would like to tell you the story about the research we've been doing for a long time. So about the hairstyles transfer task, and we started doing that since I joined the company. And the stack was pretty simple. We used a bunch of different models and GPUs for the data processing. We gathered a lot of people in our office in Tomot Center and made a special shooting. And yeah, we could warp those hairstyles. And actually put them on the people, use some painting techniques. So once we released that, actually people used it, but the quality still was not sufficient. And I can definitely say that that was cool, but unfortunately not enough. So then we got some period of time when we tried to get proper solutions from the generative models. And it was a kind of feeling that we are close, so close to the solution, but different artifacts, lack of proper data, limitations of generative models, they actually couldn't give us, some images were pretty impressive, really impressive, but still not sufficient for casual users. So, and then diffusion came into scene, and we started heavily scaling our models. And after that, we could really make very detailed changes in the texture, but on the right side, you can see that shape still didn't work well. But the approach was pretty good, and the only one thing we needed is to scale. And the diffusion transformers actually helped. And after that, you get everything. You get a multimodal approach, you can use prompts, you can provide references, you can do actually whatever you want. And most modern models are capable to do such changes. So it seems that task actually resolved, but from research side. Because if you want to serve such model for the users, you need to make sure that you have a proper cost, you have a proper latency, and that you can actually give those solutions to real users, and they should be safe enough. So let's briefly outlook what was happening with the GPUs during that moment. Actually, the performance of compute grew a lot, and new GPUs are capable to do a lot. I mean, one B200 in terms of performance is so close to the heavy compute clusters we had 6 years ago. So yeah, and one more big change, which is pretty important, is floating point operations. If you ever ask some old-fashioned software engineer about what is the most painful thing in your life, they will definitely say that floating point operations. So, but that was one of the key things which enabled actually large model storage, large model serving, and actually speeded up operations to make them, to make large models usable. But I need to mention that all those things are kind of theoretical. When you just do drop-in replacement of the GPU, you get some kind of speed up. For example, from switching for some of our solutions, from switching just A100 to H100, we got for 5 times speed up. That's not hard. But actually, this is the key thing. It's not enough. So what I want to say that the key thing are people and engineering multiplier. So there are so many different techniques you can use to get a proper solution. So flash attention, fused operations, C++ implementations of the kernels, torch compile, TensorRT, special distillation techniques which compress the models. And all of that is actually done by engineers. It's not a hardware. At this moment, model is ready for production, but it might not be servable. So if you want to show those beautiful images to real people, you need definitely to make this kind of work. And actually, this is one of the key things which make API requests in PixArt, let's say 10 times less in terms of cost than Nana Banana, like recent Google models. So let's a bit wrap up. Over past like 10 or 15 years, many things changed. But still, those people, they still do pretty valuable work, and they remain contributing to the final solutions. So if you want to make a good release, you need definitely to ask all those people to make certain efforts. So casually it happens like that. Researchers reformulate the problem, they invest time and efforts to understand what kind of product issues we have, what kind of improvements we need to do, and they try to build the data, try to build the model, they try to make something which will be better than all previous solutions. So then, once you actually publish the paper, that's not the ending at all. That's not the ending at all. You need to build some infrastructure, and you need to build a proper environment for this model to be served. Sometimes you need to use some easy-to-use frameworks. Sometimes you need to use some modern techniques like after research to get better performance. And to be honest, I've never seen in my life the most frustrating thing for everyone, like casual users, any other thing which actually frustrates everyone, when your infrastructure is down. I mean, this is the moment when everybody is upset. Besides users, clients, software engineering team, product managers, founders, and other people. So without all those things, actually you won't be able to deliver. Yeah, I think that's it. That's it.
Thanks a lot, Nikita. This is pretty impressive. We have some time for questions if we have in the audience. Okay, we have. Is this the first time that Pixart announced how many GPUs they have, or it was public information?
I'm not sure.
Thank you for the talk.
But sorry, I will answer this question. So the key trick here is that we have pretty hybrid infrastructure. It means that we have some amount of GPUs available and also scale to the cloud.
As much as you need, yeah.
Yeah.
Cool. Yeah, please.
Thank you for the talk, awesome talk. You mentioned Torch Compile, and I want to ask and turn this in somewhat framework question. Have you tried JAX, or you just use Torch in your production?
This is a pretty good question because I spent actually the first quarter of this year playing around with all available TPUs and trying to understand whether they are applicable or not actually. Besides for anybody else besides Google and a couple more companies. So I need to be honest with you. This is a pretty special decision for the company to use those TPUs. There were several certain issues. First one is pretty, the environment around TPUs is pretty small. It means that it's hard really to learn even how to use them properly. For sure, you always have a Google team trying to help you, trying to encourage you to use them, but I wouldn't advise trying them for now. But there is exception. A couple weeks ago, Google announced PyTorch support for the TPUs. This is their first release, and they worked on that like about half of the year. And we need to see how it goes, to be honest. But overall, you need to ask yourself, like, what kind of tasks you are solving, whether you need, let's say, community support or something like that, and then you're good to go. But there is a small issue, one more. They have shortage of most recent TPUs. They advise you to use V5 versions, and there's the model like TPUs of that generations, but most recent ones you need to stay in queue for them.
And a follow-up question, just a small one. Is it okay to use JAX on NVIDIA video cards?
Honestly, I was trying to approach this. I tried to code things myself. I spent some amount of tokens on vibe coding it, and after researching it, so I was trying a lot of cases. I couldn't get the same performance I could get with Torch.
Okay, thank you.